Welcome to lesson 2 of Algebra. Hopefully lesson 1 didn't freak you out too much. Today we're going to extend our understanding of expressions and start to develop a language around them, so to describe different parts of expressions. We're also going to look at equations, but before we get stuck into this too much, let's do a quick recap of lesson 1. So what we did last lesson was we started to write our own expressions where we had a variable and we did something to that variable. So in this case here, let x equal the number of items in my pencil case. So I've got a pencil case in my hand as we speak, and it's got a number of items in it. How many has it got? Your answer should be, I don't know. Write an expression for I added 10 more items into my pencil case. Now, if I said to you, how many items would I now have in my pencil case if I add 10 to it? Your answer actually should still be, I'm not sure, because I didn't know originally what you had. But we can write an expression for this. We can actually further engage in this problem by saying, it's whatever you had, Mr. Miller, which is x, and the 10 more items that you placed into your pencil case. So it's x plus 10. I removed a number of items from my pencil case. How many did I remove? I don't know. X take away y, where y is the number of items removed from X number of items. I added 4 items to my pencil case and then doubled the number of items in my pencil case. So I added 4, which is X plus 4, and then I doubled the result. Now when you double, note that what you're doing is multiplying by 2. Now think, would this be correct? Okay, because I'm adding 4 and then doubling. Well, not really. Well, not really. No, it won't be correct because order of op says that I've got to do the multiplication first. And that would involve me then saying 4 times 2, okay, which is 8. What I want to do is do the addition of the items first and then double second. So I need to force the addition to happen first by including brackets. Now what I'm going to say is this is actually x plus 4, 2, because remember we don't use that multiply sign in algebra, it's an implied multiply sign. And furthermore, that number there, as we saw in the first lesson, usually floats to the front. We express that as 2x plus 4. Now each of these are correct, but this would be syntactically the most common way we'd see that expression written, 2 brackets x plus 4. All right, I removed 3 items from my pencil case and then shared the leftover contents of the pencil case between 5 people. All right, so if I remove 3 items, that's going to be x take 3. And when I share, what I'm doing is division. I divide the contents between 5 people. All right, so what I would get then is x take 3 all divided by 5. Notice how I said all divided by 5, so I need to do the subtraction first and then share the contents. Now remember that that's a division symbol there, and we don't or tend not to use that in algebra. What we tend to use is the fraction symbol. So we're going to write this as x take 3 all over 5 is the correct wording of that. You don't really need the brackets to force it now. You can actually just do x take 3 all over 5, and this still implies that the subtraction has to take place first. Right, so on to today, the language of algebra. So a little bit about the language we're going to use. Now, when we're considering this an expression is made up of different parts, okay? Now, some expressions have things called constants, and that's called a number by itself. So it might be 3, it might be 4.5, it might be pi, it might be subtract 17. Okay, all of these are numbers by themselves. Okay, when I say subtract 17, I'm saying it's negative 17. Right, terms have one or more pronumerals or variables, or maybe just a number, or both. Okay, add that in there, or both. Here's some examples of terms. A constant is also a term. A constant with a variable is also a term, or is a term. So that now becomes a term. 3x squared is also a term. 3xy is also a term. negative 14xyz is also a term. All right, coefficient. The number written in front of a pronumeral or variable is called the coefficient. So for example, if I've got 4x, my coefficient is 4. If I have 17x, my coefficient is 17. If I have 5x squared, my coefficient is 5. If I had x, what would be the coefficient there? Well, hopefully you know that x can be written as 1 times x, which is just x itself. Therefore, the coefficient of any variable just hanging around by itself is always going to be 1. Now note that if your term has a negative sign in it, for example, negative 3x, our coefficient in this case here will be negative 3. I only want to talk about this very briefly because negative numbers forms the basis of the first unit of work in Year 8. So I don't want to get too far into that, but I do want to introduce that concept. All right, expressions are made by adding and subtracting terms, but they can also consist of one term. So 4x is an expression. 4x plus 3y is also an expression because I've made up the expression by adding terms together. 4x plus 3 is also an expression, which is a term plus a constant, or which is also a term, so that's a term plus a term. 4x take away 17, x squared, y squared, z squared. All sorts of different variations on that. And finally, onto equations. Equations contain an equal sign and are made by writing two expressions that are equal to each other or the same. For example, 4x is the same as this term here, 12. Okay, so what we're looking for is the equal sign. 3x squared y is the same as 14x plus ab. Okay, both of those are equations because they contain equal signs. All right. So let's get into this one here. Is this an equation or an expression? Let's have a look at it. All right, so there's no equal sign, so we're going to say that this is an expression because it has no equals. Identify the coefficient of PQ. So we're looking for the term with PQ in it. There's the term with PQ in it, and it has a coefficient of positive 8. You can just write 8, okay, but I want you to get in the habit of looking for the sign of the coefficient. Write down any constants. So the only value hanging around by itself is this one here, which is positive 6. Now all the terms used, so there's 4 terms in this expression. One of the terms is 3p. We could also write that as positive 3p. This one here is actually negative 4q. Okay, so that term there is negative 4q. We've also got this term here, which is positive 8pq. And this final term here is positive 6. Okay, so when you look at writing or listing the terms, I want you to have a look at the sign in front of the term as well, because that gives you the value of the term. All right, let's have a look at example 2. We've got 32 plus x is the same as 3xy plus 4z. Is this an equation or an expression? This is an equation, girls, because it has an equals sign. Identify the coefficient of x. Where's the x term? There it is there. Notice how it doesn't have a number in front of it. You can easily write a 1 in front of it. So the coefficient here is +1 or +1 or just 1. Write down any constants. The only constant there is 32, which is a positive number. All right, so the work will be set on Firefly and it's practicing those skills.